Hello everyone, welcome back to another interesting problem, and this particular problem is taken from Pathfinder. This is related to CM frame. CM frame, as you know, is very important for IIT JEE advanced examination especially. Sometimes in competitive examination, it's not just enough to have conceptual clarity. It's also good to have some skills, the strategies of solving questions, and you should be really good at. And you should be able to effortlessly change the frame of reference from one to the other. And this particular question tests that. Let's hope that you understand that and you practice well. So let's get into the question. Two small discs A and B of masses M1 and M2 connected by light inextensible thread of length L are placed on a frictionless horizontal floor. So they don't show anything over here. The diagram is completely different from that. But we get to that. There are two discs connected by string and horizontal plane frictionless. Okay. Now the disc A is held at rest, you are holding disc A, and the disc B is projected to move around A with a constant speed u in a circular path. Because the string is connected, the length is L, so probably it will go in a circular path of radius L, assuming that everything is in horizontal plane. That's what they are saying. The disc A is now released. So as the particle B is moving around, at one moment A is released. You are not throwing it, but just releasing it. Releasing meaning releasing from rest. The disc B will now move on a path shown in the figure. So that is the diagram they had given. The path that is shown side is the path of B as A is being released, after A is being released. Now the questions. First question, which disc has more mass? Knowing the path of B is like this, which mass is more, M1 or M2? That is the first part. The second one is, find the suitable expression for the step lengths P and Q. You have to calculate and find an expression, figure out how you can calculate P and Q. That's a problem here. Let's get into the solution. The first part would be to have understanding of certain essential things. So this is number one. The first part of essential is understanding instantaneous center of rotation. So the moment you release A would have zero velocity. So the particle having zero velocity would be at center of reference, and entire object system you look at A, B and string together would behave like a rigid body having rotation and translation like that. So in that situation, at this moment A is stationary and B is having u velocity, the separation between them is L, and so the angular velocity you can understand, the angular velocity is going to be omega equal to u by L, and center of mass will be somewhere in the middle. We don't know the masses ratio exactly, somewhere in the middle. But the separation RE and RB together is going to be summation L, total length, and the separation RE RB will be in the inverse ratio of the masses there. You are supposed to know that part. Anyway, now we can actually calculate velocity of center of mass also, because total momentum is known to you. After you release, momentum is not going to change. There are no external forces horizontally. So M2, that is mass of B, into U is the momentum initially. That will continue to be the total momentum throughout the motion. Total momentum upon total mass, that is going to be velocity of center of mass. This blue line you see, that is going to be velocity profile. In a rigid body, velocity is very linearly from B to instantaneous center of rotation. At A, velocity is 0. So velocity will be keep on decreasing. Okay, that's a basic idea. This is a thing that we are observing just after release, and that too with respect to ground frame. Now, if you jump into center of mass frame, you go from ground frame to center of mass frame, then obviously center of mass will come to rest. C is the center of mass I am considering. In that CM frame, now A and B will have to move around in circles, concentric circles. This particular idea is very, very important. I hope you are comfortable. Otherwise, please don't miss it. You need to spend time on it and try to solve some more questions on that. So this idea is also used in binary star study, and also when we go to modern physics where we study about Bohr's model, where modified Bohr's model, when mass of the nucleus and mass of the revolving particle are not very different. You see the motion of the nucleus is also supposed to be considered. The same idea we are going to use. Please go through this idea center of mass frame. In center of mass frame, A and B would move in concentric circles of radii RA and RB, and at any moment if you observe, initially this is the situation, at any moment you observe the speeds will be same in CM frame, but the direction of motion will be continuously changing tangential at any moment. Now velocity of B with respect to C we can write as VB minus VC, VB and VB we know it already u just after the release, and VC we have already calculated m2u upon m1 plus m2. If you just substitute, you will get m1u by m1 plus m2. So velocity of B depends on mass of A, inverse ratio of masses. Same way velocity of A depends on mass of B there. VAC equal to m2u by m1 plus m2. Also the separations RE and RB, they will also be, the center of mass will divide the line joining in the inverse ratio of masses. That also you should know, and these are all very standard results. These are all things you are supposed to be knowing it. That is what you have. I am just mentioning. And one more thing here, omega you observe, it will continue to be u by L. When you change the frame of reference, as long as you are working in translating frame, angular velocity would not change. Angular velocity in ground frame is u by L, angular velocity in the center of mass frame also u by L. So that's the point. Now let's quickly jump back onto ground frame now. At any general instant if you consider, earlier that was initial, then at any moment in CM frame, again back to ground frame if you come, now velocity of B we can find using this combined motion idea. Velocity of B in ground frame equal to velocity of B in CM frame plus velocity of center of mass. Otherwise motion due to rotation about center of mass plus motion of translation of center of mass is going to be the total idea. So the same thing we can use it for acceleration also, and also for displacement. Now if you observe velocity of center of mass, you know that it is not going to change, it is going to be constant because there is no net external force acting on. But VBC, if you go back up and see VBC, it's continuously changing its direction, but magnitude is going to be fixed. It's going to rotate with an angular velocity omega, which is u by L we have calculated. So VBC is rotating, but VC is fixed. Then now the resultant, if you consider tail of the first vector to head of the second vector, this is going to be VB there, depending on the angle turn. So these are all the essential things that you are supposed to know. Now let us get back to the understanding of the question. Now let me indicate the points over here. Let's look at the left hand side here, left lower corner. This is point 1 and this is point 2. So as the particle B is moving from point 1 to point 2, so it goes in this direction and then moves around. You can see arrow mark they had mentioned here. It goes back and then comes to this point. So if you draw tangent at the lowest point, you know it is going to be along negative x axis. I am taking right side as positive x. So V1 is going to be velocity of B at point 1, the negative x direction. And also at 2 as well, you can see it is going to be again along negative x direction. I am trying to focus on these 2 points so that I can calculate P there. So now if you observe velocity of B at point 1, and I try to use the same idea of principle of superposition, only due to rotation it is supposed to have VBC. Only due to rotation it is supposed to have VBC, and only due to translation of center of mass it is supposed to have VC. The resultant of these two is going to be the net velocity of B at that point. And they said that it is going to be left side according to the diagram. That means VBC is more than VC. Same way when it comes to 2, it will be the same repetition because it's a periodic movement. After certain equal intervals of time, you see that the motion is going to be repeated same. So VBC is more than VC, but VBC depends on M1, VC depends on M2. We have seen it already. You can go back and see VC it depends on M2, whereas VBC depends on M1. So when you take the ratio, it only be M1 and M2. VBC greater than VC meaning M1 is greater than M2 there. So that's the point we got. That is the question. First question they were asking, which of them is heavier? A has more mass than B. Now let us go on further. I want you to get an intuitive idea also whether we can get in a simpler way, very simple logical way to say that M1 is more than M2. Think about it. There are some interesting ideas that may come up that way. Now let me go on to finding P there. Now what is the time taken from 1 to 2? You see at 1 it is at the lowest position of its trajectory and it goes to the highest position there and then comes back to the lowest position of its trajectory. You see VBC has rotated 360 degrees by the time it comes here. So that means it would have completed 1 revolution, 1 time period. So time taken from 1 to 2 is going to be 1 time period. That's going to be 2 pi by omega, and we have calculated omega, which is u by L. We can simply substitute there, we got it. Now P is a displacement due to translation plus displacement due to rotation. You see, due to rotation, displacement will be 0 because it has completed one full revolution. When you complete one revolution, you come back to the same point, right? That's why displacement due to rotation is going to be 0. Only due to translation of center of mass you have it. That's going to be Vc into time period. Time period we have got 2 pi by omega. Omega is u by L. You can substitute there, you will get p value. So I hope you understood that. If you have any doubts there, please put your comments down there. I will be very happy to explain to you. So the third part is also over. First part is saying that m1 is greater than m2, right? The second part is finding the value of p there. Now we'll go to the third part, and that is the final part, finding this q distance. So to find q distance, let us zoom in and focus on this part of the trajectory. And if you focus on point 3, you see the tangent is along negative y-axis. And at point 4, the tangent is along positive y-axis. That means when the particle B is at 3, it will have a negative y-axis direction velocity. Let's call it as V3. And at point 4, it is going to have positive y-axis velocity there. So try to understand that using this CM frame again. Go back to CM frame. Let's say this is C, center of mass. And this is RB. And B is going around in the circular path. Let's say this point is corresponding to point 3 there. At that point, VBC will be tangential, you can see that, okay, and for that we are going to add VC vectorially by using parallelogram law of vector addition. I am supposed to get V3. The resultant of these two is velocity of B in ground frame, now that is V3 there. So that's supposed to be along negative y direction, you see it is like that. And symmetrically when you go to the other side where VBC is tangential again, and you are going to add VC, which is again along positive x-axis, the resultant is supposed to be along positive y-axis. So this is the diagram we are showing both rotation as well as translational effect. Now if you take out only the VBC and VC and draw the diagram separately, this is going to be the diagram. This VBC is corresponding to point 3 VBC. It is a theta below the line of VC. And over here VBC is theta above the line of OBC. This is going to be VBC corresponding to point 4. So that means as the particle goes from 3 to 4, you see that radius vector has turned this much angle, that is theta, let us assume theta plus theta 2 theta. Simultaneously even VBC would rotate by 2 theta here. So angle turned by the radius vector equal to angle turned by VBC, which is going to be 2 theta there. Now this theta we can calculate using this right angle triangle idea. You see this is theta and this is going to be 90 degrees, alright. Now if I use cos theta, which is going to be adjacent side upon hypotenuse, adjacent side is nothing but magnitude of VC in that velocity triangle, hypotenuse is VBC, VC by VBC is cos theta, but VC is known to be proportional to M2, so the ratio is going to be M2 upon M1. So cos theta we got it, M2 by M1, obviously M2 is less than M1, cos theta has to be less than 1, from this also we can tell, alright. Now I want to find a time taken for it to move from 3 to 4. You can look at the circular motion here, the rotation effect about center of mass if you consider. It is supposed to cover 2 theta angle. So the time taken will be angle turned by angular velocity 2 theta by omega. Omega you got it already, u by L, and theta also we have got it. So time taken we got it. Now once the time taken is there, now I can calculate the separation q there. So the separation q is the displacement there, 0.3 to 0.4 there. So the displacement, total displacement can again be used idea of superposition. Only due to translation of center of mass, it will have displacement towards right. That is the displacement of center of mass, which is Vc into delta t. Delta t we have already calculated, we can substitute there. This is the displacement of that point B during 3 to 4 translation, and that is going to be towards right. Only due to rotation, if you focus on individually with respect to center of mass, you see this is going to be the displacement 3 to 4. That's going to be this chord length there. That is going to be, let's say this is theta, this is going to be sine theta, sine theta. That means you will get 2 times of Rb sine theta. I am not explaining that in detail. I hope it's a simple idea only. So you see 3 to 4 is the displacement towards left because of the rotation. Now you have 2 displacement, because of translation towards right and because of rotation it is towards left, and you see effectively it is 3 to 4, meaning it is left only. So rotation effect is more than translation effect. So if I write the total displacement, that is going to be the total q that you are going to get. I just simplified it, substituted the values, and of course cos theta we got it as m2 by m1. You can check it here. From there I can calculate sine theta also, and theta is also known to you. This is going to be q value. So with that the problem is completed. This is a very very important skill based question. I don't think concepts are very hi-fi, concepts are simple only, but the application of those concepts in a simpler problem is very essential. You got to practice these ideas and you should be comfortable, not just being knowing it, but really good at these concepts, because this is going to be helpful in you in the examination to save time and also reduce the pressure on the brain and trying to think about these things in the examination. It should be like effortlessly you should be able to do it. So with that I'll conclude here. Thank you very much for your time. I hope you enjoyed it. If you have any comments, put down there. I'll be very happy to interact with you in whatever possible way. So we'll meet again with another very interesting question. Until then, goodbye.